Hi all, this is Dr. Kingston, and in this video I'll be discussing the eyelids. The objective for this video is to describe the eyelid's various components and associated structures. Let's begin. The eyelids, or the palpebrae, provide a layered, movable protective shield for the eyes and for the orbit at large. They provide protection for the eye not only from foreign elements or debris that might blow onto their surface, but they also shield them from bright lights and assist in lubricating the surface of the eyes with lacrimal fluid. From superficial to deep, they are composed of 5 layers that you can see on the right of the slide. These are the skin, the subcutaneous layer, which I admit the image here kind of mashes into a single layer, but they're considered separate. Deep to those, we have a layer that's occupied by the Orbicularis oculi muscle, then the tarsal plate, and deepest is the conjunctiva. We're going to start with the tarso-facial layer, which might seem like kind of a weird choice because it's smack in the middle of all the other layers. But because of its position here in the center, it acts as kind of a fibrous skeleton that gives structure to the surrounding layers. So this layer is made up of the tarsal plates. So there is a superior tarsus and an inferior tarsus. These are fibrous plates that help keep the shape of the eyelid so that it fits snugly against the eye. They're held in place by the medial and lateral palpebral ligaments. So here's the medial and here's the lateral in the medial and lateral corner of the eye, respectively. The tarsal plates also have 3 muscles attaching to them in this layer. 2 of them are on the upper lid, 1 is on the lower. On the superior tarsus, we have the levator palpebrae superioris muscle, which you can see here in the cartoon, and you can see its tendon here on the photograph. This is a striated muscle that elevates the eyelid, and it attaches by a broad, flat aponeurosis here to the superior tarsal plate. The superior tarsal muscle is a very small, smooth muscle. And it's not visible on the photograph, but you can see a little bit of where it's supposed to be here on the cartoon. That also has a counterpart that attaches to the inferior tarsus, which is unfortunately not shown in either of these. So that is the inferior tarsal muscle, which is also a smooth muscle and also controlled by autonomic nerves. Now, we're going to use this layer to build up an eyelid. So we're going to start by building it out externally, and then we'll finish up by building inward. Sitting just superficial to the tarso-facial layer is the orbicularis oculi muscle. This is a muscle of facial expression, and it's innervated by the facial nerve. It has 2 major parts, the orbital part that surrounds the bony orbit, and the palpebral part, which has direct connections to the eyelid. The palpebral portion is used to draw the superior and inferior eyelids together to lightly close the eye. Now, maybe somewhat surprisingly, the outermost and innermost layers of the eyelid are continuous with one another. So external to that orbicularis oculi muscle, the eyelid's covered by a layer of subcutaneous fascia and then a layer of skin up on top of that. As that skin creeps up to the margin of the eyelid here, it's going to make a pretty seamless transition into the conjunctiva. And the conjunctiva is a clear membrane that covers the inner surface of the eyelids and the anterior whites of the eyes. It is right around this transition that we find the eyelashes and a number of tarsal glands, which are going to produce an oily secretion that helps prevent the eyes from drying out. Now, I find it really useful to think of the conjunctiva as a film, or like a sheet of saran wrap that's plastered over the surface of the eye. So that part we're going to call the bulbar conjunctiva, and that's going to get plastered up onto the inner surfaces of the eyelids here. So we're going to call this the palpebral conjunctiva. Now, because this is a single continuous sheet, it prevents any sort of dirt or other contaminants from getting into the orbit around the eye. It seals it off. Now, also because it's a single sheet, it has to fold over on itself as it transitions from being the bulbar conjunctiva to the palpebral conjunctiva. Okay? We call these little folds here fornices, or fornix if it's singular. The fold around the superior margin of the eye here is the superior fornix, and the fold around the inferior margin is going to be the inferior fornix. The palpebral conjunctiva is additionally broken down into 3 regions. The marginal conjunctiva sits at the transition between skin and conjunctiva at the margins of the eyelids, so right around where the eyelashes sit. The tarsal conjunctiva is what adheres to the deep surface of the eyelid, and the orbital conjunctiva spans that little gap between the tarsal plate and the orb of the eye, so just this little area right in there. That brings us to the end of the material, so here's a practice question for you. The answer here is false unless something has gone horribly wrong. So that conjunctiva, that clear membrane that covers the bulbar part of the eye up onto the inner eyelid, is going to make a nice seal around the margin of the orbit. So nothing is going to be able to get in or around the eye unless you were to damage that conjunctiva in some way, in which case you've got a bigger problem, I think, than having some dirt in your eye or contact. All right, that is the end. Thank you guys for watching.